This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Right. Yeah. So what I'll end up doing, if there's no workaround on the system. Oh, we're recording now, so I'll chase this up for you. All right. Thank you. Hello. Okay, guys. Welcome to lecture 12. Let me just get this screen up. Hopefully, it won't take too much issues. Oh, there we are. So today we're going to be discussing generics. Before we do that, I just wanted to highlight that I did do a recording of lecture 10, and it is on the LMS for you to review at your leisure. It's interestingly enough, I had to record it another two times just because of the technical issues, but don't worry about that. On the lecture, I do sort of state that it's lecture 11 when I'm speaking, but it is actually, in fact, lecture 10, which was about polymorphism, abstract classes, and inheritance. Hopefully you find that insightful and useful. It's because it's a recorded lecture rather than a delivered lecture. I was able to sort of speed through it in a different sort of speed or pace, and hopefully you find that interesting and edifying. Some of you have had problems with Lab 5 and the peer review. I will be addressing those this week and making sure that everything is catered for and dealt with. I understand most of you did okay and got everything submitted well. At the end of this lecture, I may begin to have a basic review for your exam, but if I don't cover everything by the end of this lecture, the plan is to have a review session, maybe up to an hour review session a week today, hopefully in this lecture theatre. I say hopefully because the lecture, obviously this is the final lecture, and I just have to presume that the class hasn't been booked out. If not, I will find a venue that can support all of you and give you that information as we have it. And you don't have that on there? Oh, dear Lord. Okay. I'm not sure why this isn't giving you the correct. So I'll take this out. I will try that again. So today's lecture, oh, that's the wrong one. It should be that one out. Today's lecture will be on generics. And hopefully I'll be able to guide you as to the reason we have generics and how to utilize them. Right, hopefully that doesn't go off now. It's gone off. Oh. All right. I guess we'll just have to go the old-fashioned way. Okay. So what are generics, I hear you ask? Well, if you've seen lecture 10, if you've had time to watch that, you'll know that generics forms the third type of polymorphism. And it's a type of parametric, or a parametric type of class. And we use them when we want to be a little bit more specific in terms of how we're implementing multiple data return values. So when you have a method, when you define a method and you want to return some value, generally you can only return one type. Now, of course, that type can be a class, that type can be a primitive type or any other kind of variable, but it's specifically one type that you can return. Now, since Java 5, the generics have been introduced, which allows us to be a little bit more expressive in the way that we define the return types to certain values. So we can I'll show what I propose to do at the beginning here is show you a situation where we don't use generics and then showcase how we can face problems when we have that. And I can honestly say that during my course of development, programming in Java, I have faced the issue that I'm about to showcase you many times, and it's just a common thing. When you program a massive piece of work, you get confused as to which order certain things come in. It's very general, and because it's general, you tend to make mistakes. And hopefully, as I go through this lecture, I'll be able to convince you that generics are a very good thing to use. So generics also stop you having to cast, in many cases, your returns. So whereas I've shown you in the examples previously, you have to sometimes cast objects into certain types before you can utilize their methods, generics helps to avoid that and makes things easier. So as I just mentioned, so Java methods only return one value. But if you do want to return two, what can you do? What would be the solution? Now, if you wanted to return two values, what you could do is that you could have a class that has two values, and that could be your return type object. But the problem is that then you have the issue of how many variances of these pairs would you have to create to cater for all your needs, right? So you're coding a big piece of work and you want to have a pair of return type values coming from your methods. You have to, in fact, it's more likely that there's an infinite amount of pairs that you could utilize. So one way to do that, and this is the wrong way, should I say, or the less functional and attractive way, is to use the variable type object. Now, if you remember that the object class is the parent to all of the classes above. So if you define a class that takes in two objects, then technically you can send any two objects to that class, and it would cater for any permutation of the pairs. If you want a pair, return a pair value of variables or types, then providing a pair of objects within an object class would cover you, because you can just simply put strings in the object class, you can put integers in the object class, you can put floats with a capital F in the object class. This will make more sense as I go along, hopefully. So in that way, you wouldn't need to define a new class every time, right? So if you're going to, I'll show you some examples as well, which will help concrete the idea. So essentially, instead of having a pair class that you have multiple versions of it for each type of pair that you wish to utilize, which would become very, very clumsy, what you tend to do is you could just have one pair class that simply takes in two objects, and those objects in essence are reasonably generic. So you could put any object in there and then manipulate those and return them with your value, right, in your method. So let's look at an example of this non-generic example. So we have this class called, let's call it weak pair, and weak pair is a simple normal class, except for it takes two objects, first and second. So we're making them final here, obviously, just so that we don't have to worry about any security leaks or anything like that. We have a constructor, and the constructor is a weak pair which takes an object of first and stores it in first, and an object of second and then stores that in second. So essentially what we have is a class that is enabled or able to receive any object class and store it in the values first, two classes, sorry, any type of object classes, two, and store them in the values first and second. And as standard practice, to retrieve those values, you would get the object. Oh, can you hear me properly? Yeah. Sorry, I thought it cut out then. So to receive those values, you would simply get a get first, which gets the first variable, and get second, which returns the second variable. And that allows you to access those variables quite neatly. And of course, what we've come to expect, I think the battery's going on this, what we've come to expect is that you can then utilize the toString, because the toString is a method from the object parent class. You can call the toString on any object that you provide to this class. So if you give a string to this class, you can call the toString. If you provide an integer to this class, you can call the toString. If you provide a shark ate my hamster class to this class, you could call the toString. So it doesn't matter what the object or the type is, you can simply call the toString, and this class would be very functional. Can anyone see any problems with such a thing? Can anyone see a problem with this particular example? Sorry, I'm just checking this to see why it keeps cutting out. Nobody? Okay. So, before I go to the problem, actually, the issue, one of the issues is the fact that normally, if you want to put in an integer, if you want to pass an integer into your object class, an integer itself, as you know, is a primitive type, as is a char and a float and a double and a long. They're all primitive types. But what Java has is a built-in wrapper class. So it's like a DJ. Not really. It has a built-in wrapper class that has a single argument parameter. So if you provide an integer in a scenario where you are expecting to provide an object, and that object's supposed to be an integer, even if you provide an int, Java automatically boxes that int into an integer and allows it to utilize the integer class. So the term that we use is boxing. So when you put an integer into an int, we say that the constructor takes the int, says, yeah, it's expecting an object, so this int must be an integer, and therefore it wraps it in an integer class. And the same is true for when you you want to receive an integer, and an int, and you're provided with an integer. And the concept there is called unboxing, whereby Java just automatically takes the int value from the integer class, so that you can utilize it in your code. So essentially, it has a one argument signature. The wrapper class for every single primitive type, you have a one argument parameter or signatured method that takes the integer and puts it inside the object of its calling what am I trying to think the word I'm trying to look for? It's adjacent object class. So an int goes into an integer, a small uncapitalized float goes into a capitalized float, etc., etc. So a primitive goes into an object, essentially. Now, so boxing example, again, not a boxing example, but a placing a boxing example. In this example here, that should be a capital I. So this integer class has a variable I, and that should be a lowercase I, anyway, is equal to a new integer. So this is producing a new object of integer type called I. The new integer is then being provided with a primitive. So that isn't, we're not casting it as an integer object, we're simply providing the primitive. And obviously the way Java works is that it wraps it and allows you to do that. It's called auto boxing. And the same is true of the unboxing. So in an unboxing example, if you have a primitive of I, you can then just call the integer value, so the int value, which then gives you the primitive value for you to store within your int. And that's because integer is a descendant of objects, so objects can be manipulated in that way. So if we consider the example weak pair, so if we have our weak pair and we say P1 and we make a new weak pair and we provide the integer value, I, in this case would be 42, and then the string everything. If you think about our example here, where our weak pair is taking the first value, which is now becoming an integer, the second value becoming a string, then this example is fine, right? So you have an example where it takes the object, whether it be a primitive type or whether it be an object type, and it stores it within our weak pair object paired class, and everything is happy and everything is well. Do you agree? What does everyone think? Anyone have any? Okay, so what if we produce this example? So if we try and confuse the order, so what we have, if we have a P1 of weak pair, and that provides an integer and then a string, and then we provide weak pair P2, which also then provides a string and an integer, the pair class that receives objects will be quite happy, absolutely happy to accept that. But the issue happens then when you try to assign those values in maybe in an iterative form or in a situation where you have done a loop to propagate through your objects. So the issue is that you have an integer, you try and store this get first from P1 as an integer, it's going to be fine in the first instance because the integer P1, the first value was an integer, right? But the second value, when you call the the P2, which is the second one, that's actually trying to cast or unbox a string. And that causes an issue. Now, I've had this loads of times when I've developed software, particularly when you use things like a graphics context. So when you start working with graphics in Java, you have to provide the graphics canvas to everything that you want to display. So every class that wants to display onto the canvas, you have to provide a link or a pointer to that canvas. And unbeknown to me, whether it's tired at 4 a.m. coding something, you know, the position of providing that graphics canvas, whether I put it first or whether I put it last, would occasionally change and obviously cause a headache because of this. So obviously a solution is needed, right? So because in this condition, the IDE or the compiler wouldn't complain. So there'd be no complaints from the compiler because it's, as far as it's concerned, it doesn't know what the objects are at the point of compilation. But when it comes time to run, depending on whether the software is part of the prime software, because when you write software, you tend to have the main part of your software that does whatever it does, and then sometimes you have the software that only gets utilized, you know, once every few hours, or once every day, or once every couple of years, or like the year 2000 bug, once every millennia, right? So you sometimes couldn't even find the bug until it happens, and at which case it could be too late in terms of solving or fixing that, depending on how your projects are running. So this is an example, basically, of what's wrong with not using generics. So in this case, nothing is forcing me to place those objects in any order. The order is completely dependent on how I feel, and the results are that depending on what I do with that information, how I try to manage that information, will obviously affect the runtime of my application. Does that make sense so far? Oops. So naturally, we would hit a runtime error because P2 tries to return that string and it's not an integer. And you can't cast a string into an integer in any instance, so you'd have to have, it has to be a numerical value for that in any instance. So that, again, you only get the issue at runtime. So we need to avoid this, and we need to find a means to ensure that our code tells us when something is wrong. And the best time to catch an error is always during coding, so when you're doing your compilation before compilation. So if you can force errors to happen whilst you're coding, that's when you've got control over the code that you're developing. So the solution, don't declare an object as a pair, which you could do, or you could even use an enum, perhaps. But rather than doing such, the solution to use is to use the concept of generics. Now, I know some of you are more advanced and have programmed in Java, and you would have used generics with such things as array lists and other types of collections that you may have utilized. So when you're using more advanced Java techniques. But some of you also are just starting out, and this is quite a new concept. So the concept of generic is simply saying that the class type, it's kind of a really a weird thing to understand, but the class type, or the class that you are defining to be your multi-object class, you specify that it will take the objects, just like the object class, at any object you want, and you build the structure around that having and receiving objects and manipulating objects. But you define the order or types, the order of the types of, you provide the order of each type in the order that it comes during the creation of that object. So the form in which we define your generic type is to use these. No, this is going to work. I can do it like that. Yes, so you can see it quite clearly there. This is running out. Is to use the after the class name. When you generate your standard class name, call it what you want. You then put this angular less than bracket, and then you put in your variable, which is the variable is the variable defining a type. Now, what you have to think about is a type is almost like a clone, perhaps. If you've ever watched movies where they clone people, and then you have like a body, and this is a really crazy example, then you have a body that's neither male, female, doesn't have any form, doesn't have any looks, doesn't have any, the skin is just see-through. I've seen films like this, movies like this. Essentially, that variable is the same thing. It's waiting for an object to define it. It's completely devoid of any type, and it's simply a name that will eventually become a type. I hope that makes sense. As I go through examples, hopefully it'll start to concrete in your minds as to what I'm actually alluding to. So the form is class name, open brackets, then your variables, and the comma. Now, often, even though that says var1, you will often see, if you look at some advanced code in Java, you'll see a T symbol, a capital T. That is the norm to define a generic type. A generic type isn't a type, but it is a type, right? So this variable here is simply a vessel, perhaps. If you think of it as a vessel that will carry a concrete type at the time of you implementing or calling upon it. And you have, and again, you can have as many of these as you want, and they're all separated by commas, and they have to be different names. So you have, normally you'd say T1, T2, T3, T4, and they then become this generic type. And you make your own types, and the order in which you then present your concrete types to it will be cast during that time. I'll show you as we go along. Again, so it's often a capital T. I remember when I was learning Java, I would see this capital T places, and I hadn't been taught generics at the time. and it was the most confusing thing in the world just to see a T doing nothing that had no sort of solidity to its understanding. So what I should do, I'll show you this example first. So here's a generic pair class. So this is a class that just simply has two generic values, and those generic values will be then used and solidified in another class that calls upon this class. So you have a public class, pair, and pair then has this less than symbol. You have T1 and T2, so there's going to be two types within this generic type. You close it with the greater than symbol, and then you carry on as you would normally. So you have your T1, T2, which are now types. They're not cast, so it's not a string, it's not a person, it's not an integer. At this moment in time, it's simply a vessel, an empty vessel that will receive its type when you initialize it with an instantiation. So comparing to the first example with the object, it's the same thing. You have the first and the second. The first is now called T1, and the second is T2. These are types similar to the last one would have been an object. Then you create a constructor. The constructor then populates, or takes in, the object type T1 as a type first, second, stores it into first and second, and at that point, it's during that creation, it solidifies the type that you're going to be utilizing. And then, of course, just to complete it, we have a return type of T1, which again is a vessel, has no meaning, and T2, which returns the first and the second, and a toString. So this is exactly the same example as the object type, but this one has the added feature of using generics. The point to simply absorb into your thinking is that for T1, every time I want to utilize or manipulate the type T1, I simply use that within this generic class as T1. So T1 is used throughout. Naturally, you can use any variable names you wish, but T is just the norm, and that's the expectation. And of course, those types are then defined as objects during the instantiation. At this point, any questions? No questions? Do this if you do have a question and want to ask me later. Wiggle your finger. No? Okay. So when you want to use a generic class, you've defined your generic class. You know that this generic class is going to take any object. It's going to do whatever you want it to do with that object, but it has no content. It doesn't know what it is until you define it. So how we define it in this case is that we say, for example, as the class here is called pair, and it needs a type 1 and a type 2. So to define it, you simply call the class name, and then less than, you provide then any type that you wish, right? You have to provide two types because that's what it's expecting. If you remember, this now needs type 1 and type 2. So in this example, the first pair, called P1, is providing an integer and a string. So that's type 1 is the integer, type 2 is the string. And then it's then creating a new pair, and again, it's providing integer string as its types. So this isn't the variable name, this is the class type or the object type. And then it's providing the values for the constructor. The only difference between this and a standard instantiation of any regular object is that after the name of the class, you squeeze in the types that are required. I hope that makes sense. From the word pair, from this word pair, this bracket, the integer, and then the string, that entirety there is now a type. It's a generic type. And that is considered to be a type just like a string is a type or an integer is a type. So that can be utilized as a single type, regardless that it has the brackets. And in this case, we're using a pair, just for clarity. But you can extend that to be as many object types as you require or wish. And then again, to provide the comparison to the previous example, we then create the pair called P2, but in this case we swap over the string and the integer to enforce that order of instantiation of objects. So why it's better is that by doing so, Java can enforce, or no, even better, Java can simply tell you when you're making a mistake that you could otherwise easily miss. So it can track these changes, it can track the types to enable you to it's almost like the same concept as an interface where it forces you to adhere to your own rules. You can check that the constructor stores the right types of arguments and instant variables so that they agree. You can also check that they're returning the right types when you're placing them into a variable that requires that type. And at this point, the Java compiler or even the IDE will actually give you an error when you try to do the same thing. And if you do a mistake, it will give you an incompatible types error. So it says that's not the way you want to use this, which is a great thing when you're coding. The more sort of assistance you can have when you're coding, the better you are informed to make sure that your code is going to be running well down the line. And from a professional experience, there's never been a time in any program's life that, unless it's tiny, that you code it and it runs well first time without any issues. So the more help that you can muster in this instance, the better. So I have an example that I will try and bring over somewhere. Oh. Okay, so so I'm running this over my shoulder now because for whatever reason carrying a monitor with me is just for my health now because it doesn't seem to work in here. Okay, so I have a number of, this is collections. Oh, okay, we'll come back to that. So here's a generic class. So this is an implementation of a typical generic class of T1. I'll come to this later on in the lecture. This implements comparable. But essentially, I've just created a class, called it generic class, provided two type parameters. Those then become types within this object class. I've given them local or global, I say global, but they're, in this case, they're class variables A and B, respectively. And then I've provided the generic constructor that then populates those values in exactly the same form as you would expect. I've then provided a typical toString just to give a clean output. And I'll come back to the compare to in a minute. So that is how you define and construct a standard generic class. Any questions on that? No questions? I'm not sure if you're all just shy or whether you're just following along dead easy. But anyway, okay. So how do we use that? Let's see if I've got an example here. So an example here, I'll get rid of, so this is the example. Okay, so you have, essentially, we have this generic class that I'm calling, the class that I've just developed. I'm providing then, this is, at this point here, right here, this is where I'm defining those types, the T1 and T2. So in this case, T1, I'm defining it. T1 is a string. And then I'm defining T2 is an integer. I'm calling it gen1. And then I'm doing the same thing. I'm providing the constructor. So if, for example, this was a standard class, we would just simply say my class, I'll just call it gen, equals new my class. And then it would have some values, let's just say A and B, right? That's going to give me an error because I don't have a class called my class. But that's exactly what this is doing, except for it's providing this facility here. So if I took these out, then it would look pretty much the same as that, if that makes sense. So the only difference is that you have to define on creation of the class, you have to define the types that you wish after the name of the class, and then also provide a constructor, depending on whether you want a standard constructor or not. And then when you create the object, you have to also define at that time the types that you wish to impose upon those generic types. And why this is useful is because you can create as many generic class types as you wish using, in this instance, 2 pairs of types. You can have 3 pairs, 4 pairs, 5 pairs, and so on, as many as you need for the needs of your project. And of course, you can change the signature of the types, or this concreting of these types, for each instantiation of that class, which then allows you to return that type with those values embedded in there. Does that make sense? Okay. So let's try a quick poll. So let's see how many we get today. Hopefully we get millions and millions. Oh, I haven't got. It's not millions of you here, is there? So let me just. Oh. I'm not sure where this is going to open, to be honest. Oh, here we go. So answer the question. Let me just do a new poll. I'll call this across now. So the question is, which one of these is illegal? So I'll try and put that there. So which one of these is an illegal call? So you can see that these are instantiating, A, C, and E are instantiating what these are defining. So you have integer I, int j, string s and t, and then a pair of string and integer p and q. If you remember, this defines p and q both as pairs of the same type. So the first answer is new pair, integer, integer, both objects. If you remember, at this moment in time, obviously the generic type is of T1 and T2. So we're providing new pair, integer, integer, I and j. B is string of u is equal to q dot get first. C, new pair, integer int, and the ij. D, int k is equal to p dot get second. And finally E, new pair, this pair string int string providing ps. Right. You worked it out? Everyone happy? Anyone happy? Is everyone ready? Yep, there's one. That's good enough for me. Wow, okay. So it's kind of a mixed bag. It's the first time I've seen this outcome, actually. Shall I assume from this that you don't understand it at this point? Okay. So I can just ask an update to see. Okay, so let's see what we have. So A is saying new pair, so it's making a new pair, and it's integer of I and j. So it's creating it's kind of casting T1 as integer and T2 as integer. So then it has to provide two integers. I is an integer, great, and j is an int. So in that case, it's fine, because if you remember auto-boxing, Java will just box that into an integer because it's expecting an object, and that will be okay. So A is okay. B, string u of q.getFirst. So this is a string of u. Q is a pair, and the first is a string. So that's okay. So that would be fine. So if you said B, that's not. So then C, new, pair, is casting an integer and an int, I of j. So I of j is an integer, j is an int. Is that okay? Why is it not okay? Right. Now, whilst Java will auto-box in a constructor, so when you provide a parameter to a signature value of a constructor, it will auto-box. The generic types won't auto-box. It's expecting an object. So that one is illegal. And just to qualify the rest, D, int k, p gets second, p is an int, second is the second integer, well, that's okay. New pair. So this one, if you thought it was this one, if you recall, I said that pair bracket string comma integer bracket is now considered a type, an object. So once you define that object as your generic class, that is in fact then an object. So that's legal. You can do that. And P was of type pair string integer, and S was of type string. So that's okay. So if you said C, correct, and then if you didn't, no worries, just review the lecture and ask me questions as well. I promise you, the more questions you do ask, the more succinct I can be on issues that aren't clear when I explain them. Any questions? Nope. So yes, the answer was indeed C. So some of the pitfalls, some of the issues. Now this particular one, generic constructor syntax, this is something that's been thrown around in the community, the programming community, as a pitfall. But I personally don't see it as a pitfall, but it certainly is considered one by many. And that is that when you define, when you use a generic type constructor, when you're producing the constructor, you don't provide the brackets that are required. So there's a disparity between you creating the object and creating the constructor. Now, that I don't think of that as an issue, but it's considered a pitfall. The way I see it is that you're defining it at the top of the class, so you're kind of making it unambiguous, and you don't want to be, adding it in different locations to change that unambiguity. You don't want to make it confusing. I can't even say that. Another pitfall is that you can't instantiate parameter types. And there's a good reason for that, though. So this situation here, you couldn't simply say that first is equal to new T1 and second is equal to new T2. Essentially, Java throws away type parameters. It's called a type erasure, so that's one of the reasons. So the type disappears as soon as it's compiled, and it only looks at that type during the runtime. But another reason is that you don't know what type is going to be provided. So when you create a generic type, you have to go on the assumption that it's this vessel, this empty vessel, this clone, this I will be anything you want me to be structure, and in which case you don't know whether there will be a no signature constructor. So this example here, T1, 0 signature, so no values in this constructor, you don't know whether that type is going to be provided. And in which case, you couldn't do it. It would be illegal because you can't be generic and specify almost anything, really. You have to be completely generic for it to be a generic type. So that is the reason there for that. You can't instantiate an object in that way. Of course, as soon as you're running, you can then decide whether you're giving parameters or not in this instance. And thirdly, you can't make a generic array type. Well, you can, but it's really messy, really ugly. There isn't anything built in currently that allows you to make a nice, neat generic type array. So that's something that you would be very useful. And it is something that you would be, reasonably expected to do. But currently, that is not something that is an option as Java stands. Again, it throws away that information during compilation, so it wouldn't have a clue what was going wrong. But again, have a Google on how to just put in a generic array, Java, into your Google search and have a look at some of the examples. And it's not something that we need to cover for this class. So let's just assume there isn't a generic way of doing generic arrays for Java as it stands right now. So the workaround is beyond the scope of this subject, basically. It's just really messy, kind of a very complicated little structure that you have to produce. Okay, it's 3:07. Let's have a quick 5-minute break, and then we'll continue. I'll just wake you all up. There we are. Hello. How are you doing? Good, good.
I just wanted to ask you about for the peer reviews.
Okay.
What kind of word count should we be shooting for?
Oh, okay, yeah. You know what? I had the ability to give a minimum word count, and I figured
Yeah,
as
I saw it's really small.
yeah, well, that's what I thought. At the end of the day, I thought as long as you're concise and you feel that you've covered, everything you need to cover, that's fine. I'm not expecting more than a couple of paragraphs.
Okay.
It really is just a way of giving feedback that is constructive and not damaging to anyone who's reading it, because your peers will get to read what you say, and therefore, yeah, it really is just an exercise in that. So as long as you've understood the code, it makes sense what you've written, and it's constructive in its form, then I'm happy. I didn't want to give a stipulation because, again, not everyone likes writing as well. It's an essay of 2,000 words would be painful for some. Yeah, yeah.
Also, one of mine is uncommented. That I have, but you have 3 to review. One of them is just not commented.
That's good. That means you get to tell them.
It's kind of. Am I expected to go and work out what it does and then report on it? Because it's just a lot more work to kind of understand what they're doing.
Yeah, I do. I look. Yeah, I would give it the best go that you can, but just be honest and be factual, right? So just don't. Obviously, you're not trying to upset anyone. Everyone knows you're not trying to upset them. Just be factual and say this is what I find and this is why. And you could say it makes it hard to read. Do you know what I mean? That type of thing. But be just.
So based on that, because I've got one that's so can I just say I assume that this is what's happening. So on this assumption, I've assumed that this has happened.
Exactly. Exactly.
In which case, have you thought about an issue that could occur if X, Y, Z?
Exactly.
Okay.
But just, I would try your damnedest to understand the code, though. Don't,
Yeah,
don't be too
100%.
don't be too blasé
But
about.
of course, if
Yeah.
my code, alright, well,
No, I
the
understand.
question is like I've tried my best to say this is my interpretation. It might be
Yeah,
incorrect,
yeah.
but
No,
we get
that
that question right, and that was more easy than some of the questions.
no, that's fine. That's fine. Yeah, just as long as you're giving it your best, that should be good enough.
Cheers.
Yeah. Thank you. Hello. How are you?
Question about the feedback as well. So there's two tabs, and I use the comment feature, like I said, clicking on the direct documents. One of them was a zip folder anyway. So,
Okay.
I just used the question area. There's this huge text box. Is that okay?
Yeah, for
If I
sure.
save it, it goes crazy, and like there are these like break.
Yeah, no. Yeah, the text box. I think it's almost like a multiple choice text box, isn't it? It's really you just fill it. You just write in that text box.
It's just one text box.
Yeah, and so it's one document per.
So when I put like, I try to space things out, so it's because I've got like a long paragraph kind of feedback, and then try to,
Do you know what I would recommend? Yeah. Stick it in a Word document.
okay.
Write it out how you want it, and copy and paste.
Oh, does that fix it? Like the text box issue? Because it's all
You can
nice
stretch
and-
the text box, can't you? You know that.
Yeah,
Yeah.
I can, yeah. But then when I put it in, like when I save it and I go back in just to check that it's all good and well, it's kind of like all the break lines that I put in
Oh,
have
it's-
become code, and then everything's
Oh,
kind of
I see.
Just one chunk.
Right.
So I don't know what to do. I didn't want to use the comments because I don't feel comfortable using them, and I don't know if I could give very constructive feedback by using those instead.
Yeah.
I usually look at everything and then abstract.
Sure,
feedback
that
from
makes
it,
sense.
and
Yeah.
pass it from it, so, yeah. If it's
Just
okay,
don't use fancy formatting then. Just
No, it's not fancy. It's literally like,
Yeah,
structure.
understood.
What's wrong? This is, the
it's,
feedback.
it's kind of the limitation of the web page. I think it's part of it. It's
Yeah, so I was just wondering if
sounds
there
like
was
you're on the
a
right page
particular
though.
format that we needed to give feedback on. So.
No. We're just simply looking for honest feedback that's constructive.
We are marked on it, right? So I just
You're
wanted to
marked on what you write, yeah.
Yeah.
But if we saw
Visual
if we saw
reading,
co- yeah,
it's all chunky and
if we saw code and stuff, I don't think we'd be criticising your structure. Don't worry about that. No,
It's like
nah, we wouldn't do that. We wouldn't do that.
B and then like,
I understand
and
where it's putting the Unicode for exactly. Yeah. No, I understand. That's a limitation of the system, and we wouldn't judge you on that at
Are
all.
we supposed to receive students' feedback? Like, was it 1 or 3? Like,
You, yeah, assuming that your code has been distributed 3 ways,
Yeah.
you will receive 3 feedback on that. Hopefully, yeah, assuming everything works.
past exam papers that we could.
Are they not on the LMS yet? They should be on now.
There was no section.
Oh, okay.
In another section.
I'll make sure that's because that's something that should be up. Yeah. I thought it's probably on there if it's not activated.
Do you know which section it's on? Or, like, is
Off the top of my head, I don't. I'll make sure it's front and center. Thank you. Oh yes, thank you. I used that just now. Thank you so much. Okay. Okay, so we've essentially covered generics in its nutshell. It does get more complicated, but for the requirements of this class, that's probably as much as is needed to know. So we've already covered the compare to method, and if you recall, that a compare to method simply compares one object with another, and it provides a negative value for something less than, a zero value for something that's equals to, and a positive value for something that's greater than. And of course, as I mentioned before in previous lectures, the compare to function you have to define yourself, and generally it's very unuseful until you introduce generics. And by using generics, it allows you to specify the type of object that is being compared, and then provide a more accurate comparison for you to utilize. So this is how it's done right, rather than the previous method of just utilizing the compare to, because it's of type, it's like a generic type in itself. So the compare to, you can now implement the comparable interface, and that comparable interface, then you can provide generic values that concrete the types, or the type of object that you wish to compare, and therefore sort of solidifying its understanding of the two objects. So if I go back to my example here, let me find, so looking over my shoulder like this is hard. So you can see here that on this generic type, I've said implements, which is obviously bringing in an interface, and I've said comparable. And that is now saying that I want to utilize the interface comparable and all its methods. And the methods that are required by comparable are let me just get rid of all these. Oh, that's not going to do it anyway. Is the compare to string, the compare to method. Now, the generic part of this is this section here, where I'm specifying that the type of object that this will compare in the compare to will be of type in this example string. Now, any type can go there, of course. You can put any type that you want. The only criteria when you do provide a type is that you provide some meaningful way to compare those values. So you will simply compare the value that you're holding with the value that's been supplied. And I'll show you with an example in the slides how that works. No, it's not the slides. So, oh, I have it here, looking over my shoulder. So, oh, there we are. So the form is that you implement comparable. You provide the generic form of type so that it solidifies the type that you're going to be utilizing. And you must then have the compare to method concreted. So you will make your own version of that. And to use it, you simply call the value that you're in. So if you're in the object, so you've got, for example, you've got an object of type string. You call the object of type string by its variable name. You say dot, and you say compare to, and then you provide another object of also type string. And this way, rather than just doing object to object, which is what we've seen in the past lectures, so you just have a standard object comparing a standard object and then trying to cast all the values out of that object. In this way, you're saying, haha, this is a string, compare it to that string. And then you provide the means or the mechanism and how you want to compare those values yourself. And most of you these days, Java 5 is particularly old, and to be fair, I'm going to just go on an assumption that none of you will really see Java 5 code or below. If you do, it's because you're probably working on something that's quite old, some old service. I understand a lot of industry and government, they do hold on to old software because it works, and they don't have the capacity to absorb problems due to change. much the same as I faced a stupid big problem last week, if you recall, with my Mac when I updated. Well, it updated itself, and it just destroyed my Mac, and it meant I couldn't use it for the best part of 4 days. And the key was, and interestingly, just a side note, and changing the subject ever so slightly just to share the information, Apple released a patch yesterday, the day before, that dealt with the exact problem that this laptop had faced. Anyway, the point I was making was most companies, big companies, large, massive companies, often do not change their software. I worked for one company just the same. It was a government company, and they were still running like Windows XP on all their systems. But the key was that they couldn't afford to have any problems. So they couldn't afford to move up to a better system that would really much improve their daily work. Because if there was a problem, it would cost them millions, and it's just not worth it for them. So I'm going on the assumption that today that you'll likely just see things like Java 8 generally, or 7 perhaps. Java 5 you won't. But if you did, the reason I'm mentioning this is because anything lower than Java 5 wouldn't have this comparable interface. So if you try and use code using the comparable interface and then run it on a JVM that's older than Java 5, your code will fall. So you'll not provide the code that you think you're providing. So just be aware of when certain interfaces and functionality came in for the purpose of what you're producing in your working day. So yeah. Here's an example of using the comparable on type person. So it's a bit strange to compare two people together, but this is the example that's provided here. So this example is simply saying that if a person, we're going to compare their names, but if their names are the same, we're then going to compare their age. Of course, if their age was the same, you could then compare their date of birth, and if their date of birth was the same, you could then compare their height or something, and you could make it so that you could distinguish between two people, one way or another, unless they were twins and they were the same height, and the parents crazily called them the same name, which probably wouldn't happen. So in this example, we have implements comparables. We're then putting the generic concreted form of person. So this now means that the comparable compare to will only work on a person type. And then in the compare to, we're providing a person of object O in this case, and we're simply saying the name. This is a person class. This whole thing is a person class. Therefore, name is a person of type, or is a variable within person, compared to O.name. So it's simply taking the person that's been provided and taking the name value from there, and then it's comparing that. If that result is 0, what does that mean? It's the same, right? So if the result is the same, if it's equal to 0, then simply check. In this case, it's simply returning the results of age, this age, minus the object that's been passed age. And what that will do is it'll either give a negative value, a positive value, or obviously a 0 if it's the same. But in the event that it's not the same, that would then give you the negative or positive based on the requirements of that. So this is how you use the compare to function correctly. So if you want to compare two objects together, you use generics. And generics is a way of ensuring that there's no sort of crazy work that needs to be done to cast down and pull that information out. Unless you like doing that kind of thing, which it can be cumbersome. Now then, so any questions on generics and the compare to and any of that we've just covered before I move on? Okay, so here's the, we're going to look at the collections framework. And collections, generics allow us to use this, or to define collections. And a collection is simply a group of objects. In many ways, you're a group of students. All of you are students, assuming that you're all here as students. Gee, I thought somebody had farted then. That's the juvenile 11-year-old kid in me. Yeah, generics allow us to define collections. So generally arrays, a collection is a list, if you will, or simply, as the term states, a collection of likewise objects. And generally arrays are pretty crude. So when you use an array, it's a primitive type, unless you use the arrays class, which is, again, a wrapper for an array. But it's a primitive type that doesn't allow you to use methods and such to do more advanced structures. So Java provides several classes that these are the ones you'll likely use to store information in group forms. And the base class is the collection class. And it has a bunch of classes that basically act like collections of things. And when you create it empty. So whereas an array, you have to specify the size, and as you know, that's fixed. And I know many of you have already used a type of list called an array list and such. But essentially what we're looking for is some way of saying, look, I don't want to have to define the data that I want to store in any container and its size at the onset. What I want to do is just have a container, and as I make new things, I want to put them in that container, and that container will store them. And that is what a collection does. It allows you to put any object or any type of object into a group and access that later. But these are interfaces. That's a thing to specify. So if you remember, an interface isn't the same as a class. You can't instantiate it. Instead, you use it as a base, and then you must create an object based on that interface, or provide for all the methods that are required for using that service. So a collection breaks into sub-interfaces, namely list and map. List and set, should I say. I'm sure this is... Sorry. List and set. So a list is very much like an array in that it's ordered, and you can put as many items as you want in there, and you can index it. So it's like an array, but it's expandable, so you can keep adding to that list, and it will just allow you to have as many items as you've got memory within that structure. A set is slightly different in the sense that a set has no ordering. So there's no order. It's more like throwing things in a big bag, and it just falls wherever it falls. And it has only one value for each value that you put in there. So if you put the value 42 into a set, and then you put in another value of 42 into a set, and then you put another value of 42 into a set, and so on, you still only have one value of 42. So that's an important facet of a set. Whereas a list acts very much like an array. Then you have a map. And a map, again, I'm expecting a few of you to understand what maps are, but simply a map holds a pair and value, so a key, which becomes the kind of location of the data, and a value is the values that it stores. And these are all part of the same sort of collections templates. Often these are the interfaces that you will likely use, and they are interfaces. And assuming you've read the last lecture 10, or you've watched the lecture capture, you'll understand that for an interface you must provide the methods that the interface are instructing you to provide to utilize them, or you can use another class that utilizes those methods for you, in which case this is what we will do here. So what's available to the collections interface? Well, it has a number of methods that you will likely use. You can see whether it's empty, see whether it's got anything in it empty, which returns a Boolean. Naturally, you can take its size, and this gives you just the number of elements that are in that collection. Wow! Oh my God! Sorry, it was. Wow! There's a fly. That's a big fly. Who's got the remote control? That was huge. Oh dear. Okay, I've lost my train of thought now. You know what? I'm scared of everything since I've come to Australia. Just everything kills you. Right, I've really lost my train of thought. So you add an item. You add an item to the element E, or you add the item element E, and it returns a Boolean true if the collection has changed. You have contains. You can check if something contains. Again, returns a Boolean as you'd expect. This is remove. It removes, and again, if it's present, it returns true to say that it's done what you've asked for. Clear does what you'd expect. Clears, and then you have collection contents as an array as well. You can have them as an array. The E element is simply any type, so that's what that refers to. They contain objects, generally not objects or elements, as they're called, and the lowercase e is a variable in certain aspects, like here. So, forming on top of that, on top of the collections list and collections interface, you have the list interface, and the list interface has all the methods that are available to the collections, including these methods here. Do you know my heart is still racing just from a fly? I kid you not. Oh, what a wuss. Okay. So you have get, and you provide an index value. So you can choose an index within a list, because a list is just like an array, but it's expandable. You can set in an index form, and the E value is the element, so you're setting the index by the element to replace an object at the index with whatever it is. And the interesting thing about set is that if you do, say, change an element of, say, index 10, it changes that element, but it then supplies or provides the old elements as well. So that's a really cool feature. So if you want to just swap values, you can do that with a single command, which is really cool. Index of obviously gives you the index of an object if it's in there, or obviously -1 will be provided if it can't be found. Last index of gives the last index of a repeated value. So if you have many values in there, you get the last index of that value. Add, insert, sorry, so this, you can insert a value into the index as well, and remove those what you'd expect. The issue that you have when you're playing with lists in this form, so when you have an array that can change its size, is that you do need to be careful when you're adding or removing to that list, particularly if you're within a loop. So if you're looping through a list, and let's say the list is of size 10, and then in that loop you remove or add to that list, then the chances are that you might end up losing place or going index out of bounds if you've taken something away of that list, because you've manipulated its size during the loop. There is a function called an iterator, which I won't be covering, but I'll mention it to you. But a way to overcome that is to use an iterator to keep track of where you are. And in such a scenario, the iterator will make sure that even if you delete something, it keeps its position and doesn't give you array out of bounds exceptions when you're removing items in a loop context. And then these are the most important, one of the most important, or two of the most important structures that you will likely use, and I guarantee you will use them, is the array list and the linked list. Now, the array list is simply an array of type list that takes in, you give it its generic value, usually the classes that you want to store in there. And it expands with the data that you would give it, and in much the same way as an array. It's fast to add at the end. It's fast to get elements by the index, but it's slow if you want to add or in fact remove from the middle. So if you add something if you insert something into the middle of an array list, what it does is it pushes it into the middle, and then it pushes everything along one cell at a time, which has an incredible overhead. And the same is true as if you put an item on the beginning of an array list. So if you add an item to the front of an array list because you want to keep that on the front, almost like a first in, last out principle, then that's extremely slow. But so if you wanted to have a list which puts everything at the front, the quickest way to do that is to actually put it at the end and fill that array to the size that you need it to be, and then invert it, so you have one expensive calculation cycle rather than the amount that you would end up going through if you had to put it in the front every time. Because every time you push it in the front, all the other elements behind it has to be pushed to the next cell, and so on. Now, a linked list, on the other hand, so just to qualify, an array list is exactly like an array, except for it's really functional. You don't have to set its size. You simply define it, define what will go in it, so you're giving it its type, and then you just fill it, right? And you use it. And if you're going to be using, let's just say a small set of numbers, values, let's say you're using it for storing cards or whatever, then it wouldn't matter which order you put things in. 50, 100 or 1,000 elements wouldn't even stutter with an array list. But if you start going into the tens of thousands, 20, 100,000, a million elements, then you do need to consider the data structure that you're using, because your system will end up slowing down depending on what you're doing. Now, a linked list, on the other hand, is a completely different way of looking at a data structure. Now, some of you will obviously have already familiarized yourself with linked lists and maybe used them. For those of you who have not, a linked list is like simply having a single variable that has its elements inside. So the type of elements, just like you would with a variable called A, and it has the type and the variable value inside. But in addition to that, bolted onto it, it has a pointer that simply points to the next link in that list. So a linked list, I would be saying in list 1, and I'd be pointing to whatever's in link 2, and so on. So then link 2 would be doing the same thing. Then you maintain the beginning, and you maintain the end, so the locations of those in memory. And simply, what that means is that to add to a list, you simply change the pointer. So you can add into, adding into, it's fast to add, either at the end or anywhere, or insert. It's really fast. In fact, it's in the order of 1. But it's slow to iterate through. So if you want to find a value in a linked list, you literally have to go through each value and ask, are you this value? Are you this value? Are you this value? Are you this value? Until you find the value you're looking for. So that is an overhead of a linked list. So if your data structure is designed to throw information into a database or into a structure, keep putting information in different orders and ordering it as it goes along, a linked list is a great solution to huge amounts of data being put in. But if your data requires you to pull information out regularly, a linked list might not be the best option. So choosing that type of structure is hugely important. And again, if it's 100 elements, it won't make any difference. Your computer system will just laugh and just walk over it. It's nothing. But if it's millions, then you really have to consider the structure that you use. I would argue that most of the time you'll use an array list. It's a very useful functional method that you use. And linked list, you have also the concept of what's called a single linked list and a double linked list. And a single linked list simply points to points to the object that it's connected to in one direction. Whilst the double linked list has 2 pointers. One points to where it's come from and one points to where it's going to. and that enables you to propagate back and forth between each value. So again, very important structures, and you will likely use them. And these are obviously using the list interface. So there's a slogan that simply says that you should code by abstractions, not concretions. And what that means is that you should try and code to your lowest form. So in this case, you should consider making a list type variable, and then create a new, say, for example, maybe array list inside that list. And the reason for that would be that you could then, wherever you use that list, you can use all the functionality of a list. You can pass it around a lot more than just the array list and feed it to different places, and still utilize the array list functionality, rather than linking it to just an array list. So basically the base structure here, where you can, you should try and keep it as low down the structure as is functional to your needs. It's just a generic consideration rather than a legal or illegal act, if you know what I mean. So you can, but you should consider doing that where you can for simplicity of your coding. So, in terms of how to create an array list, so I have to look over my shoulder again. Let's just go to the main. Can't even find my mouse. Here we are. We have an error, so we'll get rid of that. So an array list, you would simply say array list, got that right, and then you would give it the generic type that you're going to do. Let's just argue that it's a string in this case. And you give it your value, and we're just going to say array1, and then you say equals new array list string, and then you provide the empty the empty constructor, and that's basically an array list. And I think I have examples on the collection. So yeah, so much the same way. List example using the add function. It's simply, they look the same. But in a list you will add. Use the keyword add. In a map, which I'll be coming to next, actually, where you use the keyword put. In the example of an array list, to add to an array list, you simply use the name of the array list, array1, dot, and then you say add, and you provide the value that you wish to have, like so. And then that's got one cell of value, Thomas, and so on. And of course, all the commands that I showed you with the list are available to the array list as well. Any questions? Okay. So a quick, what does this print? Before you do, hang on, before you do, let me just try and, new poll. Oops. Oh, new poll. Right. So, oh, you can't see that, can you? So, what will this print? Ooh. So cast your votes. What will this print? So you've got an array list. You're adding to the list in different ways. And then you're iterating through the list and printing. Oops, sorry. Here we are. Using print, not println, the value. You got your answers? Everyone convinced they've got it right? I'm expecting to see everyone with the same answer now. Okay, here we go. Say no if you don't want me to go. Okay. Right. Okay, so majority D, and then the next C with some on A. Okay. So, array list, to make a new list, these are just adding. So one of the key features with an array list is you add to the end. So you're always adding to the end. So you add 1 to the beginning, then you add 2 after 1. So we have 1, 2. Then we say list add 1, and this means that it wants to add it now to the index value of 1. So in 0 we have 1, in 1 we have 2, so in the location of 2 we're now putting 3. So now we have 1, 3, and 2 is pushed along. So if we have 1, 3, 2, so far we have only one of them. No, we have, yeah, we only have this one, don't we? 1, 3. And then again, the same thing happens. So now we have 1, 3, 2, add list, 1, 3 is in the location. So we add 4 to the location of 1, which is where 3 was. So where are we? 1, 4, 3, and 2 should be the answer. So if you had D, you should be correct, assuming that I'm correct. And if there was any of the others, that's why it was that. And of course, this is just the simple way of looping through an object list of type array. And so for every string S within the list, just do this, essentially. So let's have a look. Oh, there we are. So, yeah, 1, 4, 3, 2. Did you get it right? No? Yes? Okay. So a set is another collection that you can store values into. Again, it's an interface, so you can't instantiate it directly. If you did instantiate it directly, you would have to supply all the methods that the set actually holds and produce meaning to all of those, which you wouldn't want to do. It doesn't preserve order or duplicates, so when you have a set of something, you simply throw it into the set, and that set then has that one value. So it's actually a great way to throw in, say, student numbers or something. Maybe not, because it doesn't preserve order. But it's a way of keeping things together in one container that you don't need to iterate through them in any particular order. Excuse me. But it's super fast to find. So if you have a value in a set, it's extremely fast to find that value, and that's one of the sort of strengths of having a set. So it's constant time to find the data, rather than you don't have to iterate through anything. You simply locate the value under its sort of pseudo name in the memory. Set doesn't provide any methods beyond those of the collection, so whatever the collection has, the set has. And then you have different types, actually, but hash set is a method of implementing a set. So you would say set, generic form, name of the variable, equals new, and then you'd say equals new hash set rather than set. And that would then, so the hash set would have implemented all the interface methods that are required to run a functional set. So that's one of the key features of set. Then we have a map. Again, map is an interface. Interestingly enough, when I was playing with maps over the last few days, just to look at the examples, some of it has been, I think, a hash table, I think it was, that I was utilizing in the past, has actually seen the ways of the dodo. It's gone extinct, so you can't use certain things. Actually, on mentioning that, so when you do utilize certain commands within Java, you do need to ensure that those commands are still being maintained. Usually 1 or 2 iterations before things are removed, the Java tends to give you warnings that this is soon to become obsolete. And in this case, obviously, a hash map is now obsolete, and other forms are used. I think it's a hash. Is it hash map? No, not hash map. Hash. One of the hashes that I used to use a lot back in a few years ago. Anyway, so a map is very similar to if you've done Python, a dictionary, or a lookup table, or a finite function. It simply holds a key value and a contents value. So you have a key and values, and those key values form a single element. So that element becomes the actual index or the value of that map. Again, it's a way of quickly finding a value. So usually a map would utilize something called a hash map. Now, hashing is something that you may or may not have studied. I won't be covering it in this class, but it's just the way that the computer structures the location of values. It has its own interesting field of study, to be honest. But what it means is that a hash map, you can access information very, very quickly and store within that key any other object to your pleasing, so you can have quite a varied amount of data. Often when you do, a dictionary is a very good term to use for a map, because just like a dictionary, you'll have the value that you're looking for and then some description of that value. Or some more information pertaining to that value, and that is very much like a map. A map can only have one insertion, so one value, the key, a single key, so you can't have multiple copies of one key. It has to be just one key. If you, again, provide the same key over and over again, you'll still only have one key, so that's the K value. And the K value is almost like the index. Except for rather it being just an integer, it can be generally a string or some other value like a char or something. And again, it's incredibly fast at finding or locating individual values. And again, these structures, I would expect you to use them in your programming endeavors. So when you start coding, using maps and collections just becomes part of the process. But which one you choose will, I would argue, if you've not studied data structures very much already, I would argue that you probably should find a class that studies data structures in more depth, just so you have an understanding, particularly, maybe only if you're going to be working on large volumes of data. So if you're going to be using just tiny amounts of data, you could just stick with an array list for everything. You wouldn't have to worry. But the minute you start going up to the tens of thousands, and if you're going to be doing anything of value, you probably will be using the tens of thousands. I'm getting attacked by the remote control fly. Blimey neck. Oh my God. Oh. Crikey. There's my heart going again. What was I saying? Oh, gee whiz. Okay. So a map has its own list of, probably the wrong keyword, its own methods that can be utilized. Again, isEmpty is a common one. And of course, these are also ones that I utilized in addition to those of a collection. So you check its size. Again, its size gives the value of the pair. So if you have a single value, a key and a value, it's not two items. So it'd still give you one item, because the key and the value form a pair of connected data elements. So you've got the get object. These are the standard stuff that you'd expect. It returns the object mapped to by the key. So when you search a map for your item, you're not searching for the value that you're looking for, you're searching for the paired key. So if you're looking for Bob, and Bob holds, you know, the location of the treasure, then you have to search for Bob, not the location of the treasure. So that's one of the key structures of that. So again, put rather than add. So puts a value into the structure, and if there is the same value in there, it'll return the old value. Again, there'll only be one key, so it can only support one key value, one key value pair. Remove would do exactly what you'd expect, but it will return the mapping for the key, and void clears it pretty much. So that's pretty straightforward. And again, this is an interface, so what that means is that you do need to utilize a concrete class to utilize a map, and usually you would use a hash map. So you would say, again, like I said, map, generic form, name of the variable, equals new hash map, generic form, and then the constructor signature, which gives you the utilization of that. If you don't, if you said map generic variable equals new map, then the ID will say, well, this is an interface. You now have to implement all of the methods that are available to this interface, and it will just, all these things here will be thrown out as throwable methods, and then it'll be your job to do something with them. So that's probably not the best use case scenario. So in summary, what we've covered today, generic types basically have parameters written in angle brackets. So when you have a generic type, you use the less than and greater than angled brackets, and you put in your types in separated by commas. Parameters are type variables which can be used as types in the declaration. And yeah, so the parameters should be reference types. All primitives have wrapper classes, and Java will usually automatically convert if they put inside a parameter portion. But just remember that all types that go into the angled brackets must be of object type. So you can't put a primitive type into a generic form. And you'll usually use an array list often instead of, actually on saying that, I would argue that if you know categorically how big your data set is and it's not going to change, then I would still advocate to use an array simply because it's more memory efficient and it's quicker to utilize. It has a smaller footprint. It doesn't have all the methods overheads that the array list has. But if you need an array that's expandable, you'll likely use an array list quite often, or for all sorts of lists, or a hash set, or a hash map, or various other implementations of the collections array. I don't know why this thing likes me so much. Anyway, right, are there any questions at all? Of course, this is our final lecture. Hang on. Oh, you can't see that there. So the next thing, what I was hoping to do, hopefully, like I said, next Monday, if I can, I will certainly confirm or deny that it's possible. I'll have a review, a lecture, and it's not going to be a lecture. Let me qualify. I'll have a review session, and I'll simply just overview what we've covered and give an opportunity for questions. And it should be very casual. If there's no questions, then we can finish. It won't be very long. If there's lots of questions, it will last a longer time. So the excuse me, the review session will be about you bringing your questions and hopefully me being able to answer them, to give you that little bit of solidity in your understanding. And hopefully that will be next Monday around the same time. The one thing I wanted to showcase was, oops, I don't know, why isn't that working? Okay. Was that you have your exam on the 5th of November, right? Am I correct? And it's at 12:15 p.m. at the Royal Exhibition Building East. I will put it, it was mentioned to me that there was no exam paper solution on the LMS. I'll make sure that everything's put up there tomorrow. I'll make sure that everything is taken care of. All the codes that we've been working on, I'll make those also available tomorrow. I say tomorrow because I know I've got some meetings after this lecture which take most of the evening. So, and unless there's any other questions, are there any questions before we bid adieu? No? Yes, I had one. Yes, I've sent an email to the tutors only this morning to make those live. The solutions, what you don't see is they are there, but they need to be activated. So I'll make sure they're all activated as well. In fact, I might be able to do that this evening, thinking about it, just because it's a very short process. But yeah, any other questions? No questions? Well, in that case, good luck with the exam, guys, and thank you for being a great class. Thank you.